I'm Bill, Alpha Alpha 4 Quebec. And we're passing the microphone around and see if this works a little better.
Mike, N7MW.
Lee, KY7M.
Ned, A7A.
Gary, KC7CS.
Walt, NJHE.
Virgil, K7VZ.
Okay, I should still be. So Tim, I see that you've joined. I hope you can hear me okay. It looks like you're still muted, but thanks for joining us.
Yes, I can hear you fine, and it's a pleasure to be here.
Okay. We just handed the microphone around, the 8 of us in the room, and introduced ourselves. I don't know if you were listening when we went through that. Do you guys online want to real quick introduce yourselves, name and call sign? I see N3PS. Each of you just go down the list real quick. It should take about 30 seconds.
Jim, KC1BB. Steve, K7SP.
Mike, KC7V. Ron, N7RD.
Mike, K7ING, home with the Canadian Coronis.
This is Bob, NA7RH. Who else is there? Tom, NQ7R, incognito.
Where's Jim? Where'd he go? Sheriff 78.
Where's Cognito?
Under share screen, I think is where it was, or maybe it was under participants. Advanced sharing options. All participants can share. Okay. Let's show that, step down a couple of steps.
Yep. Should be.
Okay. Okay, so we just did our meet and greet. Let me introduce Tim, Kilo 3 Lima Romeo from Pennsylvania. I was reading about his superstation on his QRZ page, and he works for DX Engineering, so he'll be presenting to us today about building antennas. And since it's 10 o'clock there, let's let him dive right into it. Tim, go ahead, and thank you for being here.
Well, thanks so much for the invitation to talk to everybody tonight. And clubs are the backbone of this hobby, so I'm always thrilled to talk to the club. And I see my good friend Mike, KC7V, and I was on the phone with Lee, KY7M here just a minute ago. So familiar faces. And also we have my friend who used to be in Western Pennsylvania, who's a guest on here tonight, Josh, K3LH is also here, who lives in Arizona now. And I'm sure he would like to meet up with many of you. So let's, I'll share my screen and we'll get started. And we're going to do a little jog here to get things going. And let me know if you see my screen okay.
Yep.
All right, great. So we're going to go over a few of the physics parts of antennas before we get into the building part. And you know, think about what an antenna is. And it's really a very cool device because it converts the RF power that we have out of our radio transmitters into electromagnetic radiation and then sends it around the world, which is really cool when you think about it. And then also it reciprocity exists, so that it acts as a receiving device to actually put energy into your receivers. And remember that any conductor through which RF current is flowing can be an antenna, and sometimes those are unintended antennas. And so we have to be concerned about that as well. One of the great things is antennas can be configured to put together directivity or gain. So you can actually make effective radiated power, which is really cool because you can make more power because of the gain of the antenna. Feed point impedance is important because we want to match the feed point impedance of the antenna to the coax impedance to our radio impedance. And when all those three things line up, everything is good in the world. And we operate on a number of frequencies, so we want to make sure that antennas have bandwidth as well. Remember that an antenna that does not transmit very well is not going to receive very well either. So that's part of the reciprocity theorem. The near field is important because we don't want to be too close to our antennas. And the far field is important because that's what we work DX with. The dipole antenna, very simple antenna, but a very efficient antenna, very predictable antenna. And 468 divided by frequency. The 468 comes from the effect of ground. If you remember, 492 divided by frequency is in free space, but the 468 tries to take into some accounts of the what happens when you put a dipole above ground. And you get about 2.1 dBi. Now you can get more gain if you extend the dipole to make it a full wavelength long. But the problem is that the feed point impedance becomes complex. The best way to handle that is with open wire feed line, like 450 ohm feed line. And if you run it all the way to an open wire tuner, even though the SWR is high on that feed line, the loss is very low. So, you know, that works out just fine. But if you were to feed this with coax, with the SWR getting high, the losses would kill you and the antenna efficiency really goes down. But look, you get 3.8 dBi, so almost 2 dB more just by extending it to a full wavelength. If you want to go even further, so this is 2 5/8 waves in phase. Again, the feed point impedance is complex, but that's no problem for open wire. And you get 5 dBi of gain, almost 3 dB more than just a dipole. And you can use a dipole on several bands. Again, feeding it the entire way with ladder line is the best way to go because the losses are so low, even though the SWR gets high. You can have vertical dipoles as well. Those are popular on the VHF bands. And a quarter wave vertical is a popular DX antenna because it has, you can see the pattern has got a lower takeoff angle than what a dipole has. And the self impedance is in the range of 50 ohms. It's pretty close. So the match is really good to coax. And but the secret to making any vertical work is having radials. And that is really the important part because that's the other half of the antenna. So the importance of ground when it comes to these vertical antennas, that you want to minimize the losses because ground is not a very good conductor. And so having that radial system is really important. It can be made of any type of wire, and the radials just extend from the feed point like spokes on a wheel. And you can have elevated counterpoise wires as well. And so here is some examples. You really need to have in the range of at least 30 radials to make a good counterpoise. And you can have shorter verticals that are less than a quarter wavelength long, but you need to make sure you have a matching network at the base of the vertical for the best performance, because otherwise the SWR will be high on your coax, and that will decrease the performance of the system. So, you know, that feed point impedance can get quite low, and you want to have a matching network there. An inverted L is a really good antenna for 80 and 160 meters. And just by having a series capacitor, you can match this. And sometimes you don't even need that for an inverted L, but a very popular antenna on 160 meters. And you can use a vertical monopole on several bands like the 43-foot vertical. But again, you want to have the matching network at the base of the vertical. That is for the best performance. Here's the Delta Loop, a popular antenna as well, one wavelength of wire, easily matched to 50 ohms with a 75 ohm quarter wave matching section. And depending upon where you feed these loop antennas determines whether it's vertically polarized or horizontally polarized. Now the Yagi. Yagi is one of my favorite antennas, and it has a driven element, which is the only element that is excited. The rest of the elements are parasitically fed. And so we start with the 2-element Yagi, which has about 6.2 dB of gain. Depends upon whether you do a reflector or a director. You can do either. There are trade-offs to doing the one versus the other. And it's not possible to have the best impedance, the best gain, and the best front to back all at the same time. The Moxon rectangle is a really good derivative of the 2-element Yagi. I have two 2-element Moxons here on 40 meters, and they are outstanding antennas. The great thing about the Moxon is the feed point impedance is 50 ohms, so no matching network is needed. The gain is good, about 6 dB. You got great front to back. It's more compact than a Yagi or quad, but it's harder to make because you have to bend the elements. 3-element Yagi, so adding a third element. In this case, you have a reflector, driven element, and a director. And by using computer modeling optimization software, you can optimize the parameters for feed point impedance, gain, and front to back. So here's the 3-element Yagi, the reflector a little bit longer than the driven element, the director a little bit shorter, and some standard spacings. You can have larger Yagis that have more than 3 elements. And so what you're doing is adding directors, and really good Yagi designs are found in the ARRL antenna book. And they can also be created using antenna modeling software like EasyNet, which is now free for downloading. The 4-element Yagi, a reflector, the driven element, and then 2 directors. And stacking Yagis develops more gain. So here we have, this is for 2 meters FM, but the principles are the same. You've got a 5-element Yagi here that probably has about 12 dB of gain. And then you add a second 5-element Yagi spaced a half wavelength apart, and you get 3 dB more gain by adding the second Yagi. So here are some typical Yagis for 6 meters and 10 meters. The 6-meter Yagi is on top, and it has a folded driven element. So that's 200 ohms feed point impedance, then using a 4-to-1 transformer to take it down to 50 ohms. A 3-element 10-meter Yagi using a gamma match. And simple antennas for 2 meters can be made, or 440 can be made from just an SO239. And you see the radials are sloped. And the reason the radials are sloped in this ground plane is that because that makes it a 50 ohm feed point impedance. If they were at 90 degrees, it'd be about 36 ohms. Here's one for 440 done on a BNC, same principle. But we lost it here. Get back to, there we go. So we have the quarter wave radiator that is over here in A, shows the radials at 90 degrees, and that will give you the 36 ohm feed point impedance. Over in figure B, those radials are sloped down on purpose to give a 50 ohm endpoint impedance. Here's the here's an M squared Yagi. This is on 15 meters, and it has a beta match because the feed point impedance here is about 36 ohms. Actually, it's even lower. It's about 25 ohms. So the beta match allows us to step it up to 50 ohms. And then this is an ugly balun, and it's ugly for two reasons. This is 5 turns of RG213 coax. It's ugly because it looks ugly, and secondly, because it doesn't work very well. There's not a whole lot of common mode impedance. It's much better to use ferrite beads or a ferrite core as a choke because you don't want the feed line interacting with the antenna. Here is an 8-element 10-meter Yagi. So there's a reflector back here, the driven element, and then 6 directors. And you can see the first director is very close to the driven element. This is known as an optimized wideband array, which is very popular in Yagi construction. All of the antennas here, except for the Moxons, are of the OWA design at K3LR. Again, this is 15 meters OWA with the first director very close to the driven element, and using insulating material to insulate the elements from the boom, and then attaching the feed line directly to the driven element because the OWA allows a 50 ohm feed point impedance directly without a beta match or a gamma match. We talked about Yagi stacking, and so here is a stack of 4 8-element 10-meter Yagis here at K3LR. And how this goes is one of these has 14 dB of gain. And then when you add the second one, you get another 3 dB. So that gets you up to 17 dB of gain by adding the second one. To get another 3 dB, you have to add 2 more. So this gets you to 20 dB of gain. And you can always use a ring rotator to rotate Yagis around the face of a tower, which makes use of important real estate. When you're constructing Yagis, it's important, no matter what antenna you have, it's important to have clean connections. So here at K3LR, we always take and make sure that we get the aluminum oxide off of the aluminum before we put the antennas together. And then we use an antioxidant. I like to use Jet Lube SS30. This is available at DX Engineering, and I've used this for almost 30 years now. And it was recommended to me by W3LPL, and it's fantastic stuff. It does not dry out like Penetrox does, and it just works very, very well as an antioxidant. And you can see putting together these Yagi elements, again, getting very clean aluminum, and then having the SS30 to make sure that we don't have any oxidation. And we want to make sure the conductivity of the elements is good when we put them together, because we're going to interlace these elements. And like I said, it doesn't matter if you're building a tri-bander or a monobander, any antenna, you want to make sure that you have very clean elements with antioxidant. I like to use cross pins. So I drill at 90 degrees. This is a homebrew Yagi. This is actually elements from the 40-meter Moxon. And you can see the cross pin elements. And you can also see the orange SS30 that is around. And this is some 15-meter elements, director 4, again, the cross pins, and that is holding everything together. The driven elements, so this is the feed point where we will hook the center conductor and then the shield. More driven elements, center conductor and shield. And here is the construction of one of those 2-element 40-meter Moxons. And this is the driven element over here. And you can see there's a ferrite bead balun. This is 40 number 31 beads over the RG213 coax. And that acts as the choke balun for the 2-element Moxon. And here's the feed point of the 2-element Moxon using the DX Engineering feed point connector. So here's the RG213 coming from the ferrite beads, goes into the feed point connector. And then the red is the center conductor. The black is the shield. And that's very important that you know where the shield is, because if you're stacking antennas, you need to make sure that the center conductor and the shield are on the same sides of all of the antennas in the stack. We always put the center conductor on the right-hand side if you're standing on the tower, and that's what the red tape is to remind us that right on red. Construction of a 10-meter Yagi, and this could be for any band. This showing the overhead boom riser that holds up the boom, as well as one of the element plates. And then leveling the element plates using the DX Engineering clamps, using Nylox and SS30 as well. And getting all of the plates level. And these plates are available at DX Engineering if you want to build a monoband Yagi. You can see more of the construction here using the stainless steel clamps from DX Engineering and making sure everything is clean. And we've got antioxidant here and everything is leveled. Showing the end of the boom. I never put caps on the element tips. Don't want to trap water in there. I do put boom caps. This is a 3-inch boom, but I also cut a hole in the bottom of the boom cap to let the water out. No matter what you do, water will get in, and you have to have a way to let it out. There's nothing worse than having a boom full of water. And the overhead guide truss. So this is the holding up the boom going to the guide truss. This is Philly strand. I like to use Philly strand for the guide truss. This is the guide truss here, showing the turnbuckles and the plates, and the upper plate with the turnbuckles. And this is a 2-inch piece of pipe from it's aluminum pipe, and then connection to the boom of the overhead guide truss using stainless steel eye bolts. Another view of that guide truss holding up the boom. All the elements are now in place. They're all level because we leveled all of the insulating plates. And you can look down here and everything is in line. And this is the choke, 40 number 31 beads on the RG213 coax from DX Engineering. And using high quality Amphenol 83 1SP connectors. I can't emphasize enough how important it is to have good quality connectors, not Hamfest specials, and also install them correctly. This is the driven element plate, and now the driven element is in place, showing where the shield and the center conductor will be attached. DX Engineering clamps, and the feed point connector right on red. So here's the center conductor, here is the shield. And here's the number 31 beads as the choke, which is an outstanding choke for 160 through 10 meters. Another view of the choke. It's better to have the choke mounted off of the boom, because if you put this choke against the boom, it detunes the choke and makes it less efficient. It doesn't have as much common mode impedance. And as was stated at the beginning, take a look at the website, K3LR.com, for lots of photos of antennas and drone videos, etc. And also tune into onallbands.com for lots of great blogs on all sorts of topics for amateur radio. That's the DX Engineering blog, onallbands.com. And that is my presentation. I'm available for any questions.
Now I'm unmuted. Okay. Thanks a lot. That was great. I've got a couple questions, but I'll let the room and the folks on the Zoom meeting go first. And that'll give me time to forget what my questions were. Anybody in the room want to ask? We've got a microphone here to hand around for the first time ever.
Hey, Tim, this is Ned, AA7A. How you doing?
Hi, Ned. It's great to hear from you.
Yeah, I've been waiting for you for DX Engineering to make your big new rotor available. Is that in stock yet, or is that what's the status? I know it's crazy times with the supply chains and all that, but what's the status on that?
It is days away, Ned. I can tell you that I was at our manufacturing facility in Ohio yesterday, and we are assembling rotators as we speak. So they will be on the shelf very soon. And when they hit the shelf, it will be all over social media, all over our website. I am so excited about the rotator. It's going to be, it's just awesome.
Yeah, you can't have one too big. I know from experience. Otherwise, you're hiring Hector every couple of days.
That's right.
Okay, that's it for me. Anybody else?
Any idea of a relative price point on that, Tim?
Yeah, the price for the rotator is $24.99. And if you get in early, if you get your order in now, you actually get a free mast clamp with that. So you have to pick a 2-inch or a 3-inch clamp. And that clamp is free if you order now.
Great, thank you.
For your elements, what material are those plates made out of?
That is G10 fiberglass. So, and like I said, we are in the process of stocking those plates for the various bands at DX Engineering. If you want to get plate material ahead of time, McMaster Carr has that. That's where we get it from.
Yeah, this is Ned again. One more question on the rotor. Is that Green Heron controllers work with that rotor?
Yes,
Oh, good,
they work very well.
perfect.
Anybody else on Zoom have a question? Okay, this Bill, Alpha 4 Quebec, and I'm also the club president this year. I had 2 questions. One is, especially on the beams that you were showing, and you had a word for them, where the driven element is basically insulated and goes directly to the feed line. There appears to be no DC ground to the tower. Is that an issue with lightning or static buildup? Or how is that handled downstream?
Yeah, that's a great question, Bill. No, there is no DC ground. And so for instance, on the M² antenna with the beta match, there's a DC ground there. But there's not with the OWA feed. I did experiment a few summers ago by putting chokes to ground from each side of the driven element. And that worked out okay. But and in Arizona, where you have more lightning, that might be an issue. And using some, 100 microhenry chokes to ground at the feed point might be a good thing for static discharge, but it's not been an issue here in Western PA. But the shield gets to a DC ground, obviously, because it gets attached to an antenna switch that is on the tower.
And the other question I had is, you have you showed the end caps on your 3 or 4 inch boom, presumably to keep birds out, and you cut a little tiny notch in them for drainage. But if you tighten that, there's a word for it, the truss that holds the boom up. If you tighten that up just right, you could end up with the boom being higher than the center. Do you have another drain hole in the center, or could you fill it up with gallons of water in the center?
Yeah, that's a great question, Bill. And the answer is that we don't tighten the boom that tight. The boom sags about 2 inches from the center. That's done on purpose for mechanical reasons and also for drainage. So there's no problem. We do not tighten that boom so that the end of the boom is higher than the center.
And this material, this, another one just popped in my mind while we're waiting to see if anybody else wants a microphone. The material you use, the orange material, SS30, I think you called it, you even put that where the clamps on the boom connect to the insulator, where it would seem to be completely unimportant. Or is if there's corrosion or oxidation in there, does it form a diode that creates issues, and that's why you use it?
Now, the reason we use it there is as an anti-seize. It also works as anti-seize on the stainless steel bolts.
Okay. Anybody else in the room want to grab the microphone and ask a question?
I see Jim on Zoom there, Bill.
Anybody on Zoom want to ask?
I got one for you, Tim. What's the best way to get that SS30 off your hands?
I still can't get it off my hands. It's on the cat. It's on everything here.
Okay, I'm just curious.
Yeah. It's tough.
Jim, were you about to ask a question?
I was going to, yes. Tim, can you compare those comments with the other antenna that seems to be very popular? That's the loop fed array.
Oh yeah, yeah. The loop fed array is a really good antenna. You know, and I've had a lot of great discussions with Justin on that. I've never compared an LFA against the OWA, so I don't have any hard data on whether or not, you know, one's quieter than the other. I just don't know, but the LFA is also a very good design.
Yeah. Come out here with one of each and compare them in the noisy static environment. Let us know.
Okay, I'll do that, Jim.
Thanks.
Tim, K7SP, in one of the pictures you were showing, I believe it was one of the Yagis, it looked like you were having a coax choke as well as the ferrite bead common mode choke both together. Did I just misinterpret that?
Yeah, no, there was a coax choke that was on the Betamax antenna from M squared. And then all the other ones that I showed was the ferrite bead chokes.
Okay.
Hey, Tim, Paul Schwartz here, N3PS. I was noticing your elements in terms of connecting them, you're using bolts or pins in lieu of clamps. How do you do your adjustments then for tuning purposes?
Well, the great thing about antennas these days, Paul, is that I just build it like the computer tells me to build it, and there's no adjustments. You don't have to tweak anything. You don't have to tune anything. It is amazing how well the model is the real world. So I just build it like the model says with a lot of confidence now. And the SWR curves, the gain, the front to back fall right into place.
All right,
Tim, what are you,
very good.
Tim, what are you using to model your antennas?
Yeah, it's Easy Neck. And then an optimizer from Dan out in California, Dan McGuire. He posts a Tower Talk every now and again, but there's an optimizer that he has that bolts onto Easy Neck. And I forget Dan's call sign, but Dan McGuire's optimizer that works with Easy Neck, that does it. It's perfect.
Nice. Thank you.
Just push the button and it works.
It works. You know, you got guys come here to take a look at this stuff, and I said, "Well, how did you tune it?" I said, "The computer does all the tuning."
I have another question. What kind of tape are you using over those ferrite beads?
That's Scotch 88, Paul.
80. All right. How many rolls did you go through?
We go through a lot of tape here. But fortunately, we sell it in bulk at DX Engineering.
Oh, it sounds like that's a wrap.
Oh, can we bleep that one out too, please?
Okay, any other questions from the Zoom meeting or from the room? We got these cool new microphones. You guys in the room want to ask a question? Okay. I appreciate you coming and speaking to us at 10 o'clock at night. This was actually a very interesting presentation. And hopefully we'll hear from you again on some other topic.
Yep. Bill, thanks so much for the invitation. You've got a great club and your hybrid is working great where you've got in-person and folks on Zoom. And one of the things we do have, I guess we've got 8 different topics. I've got 8 different slide decks. And so you just talk to Terry and she'll figure out a good day and time. And to those of you who are DX Engineering customers, thank you so much for your business and your trust. And I hope we've done well for you. If you haven't tried DX Engineering, give us a shot. We do have a large inventory position in Sparks, Nevada. So Arizona customers get served out of Nevada. So you get really quick service for ground. And give us a shot. I think you'll be pleasantly surprised how well it goes.
Great.
Thanks for all
Tim.
you do.
Thank you.
What?
Good
Thank
to
you,
see
Tim.
Thanks. 73, Mike.
Thank
you later.
Thanks for all you do, Tim.
You're of course welcome to stay, or you can drop off at whichever you prefer. We're going to get into our brief, since there doesn't seem to be a lot of cookies or sodas to drink, we'll just get into our business meeting. As soon as you bring up the presentation. We don't have a lot. Okay. You got the questions part done? Okay, Treasurer, Mike, do you want to talk to that for a second? With the microphone? With our cool new microphone? Yes, stand.
Close enough. Okay, we have a grand total of $9,454 and change in the kitty right now. Just wrote a check for $110 for the room rental today. And that's really been the sum of the activity for the last couple of months is room rental. It's
We've got to pay for some
pretty
microphones,
slow. We have, what, 121 paid members to date. That is my report.
Okay. And as I hinted at a moment ago, we will have an upcoming expense to reimburse for these microphones. It's a couple $100. I think it's worth it. It's working out great. Next. Okay, we just learned today that our scholarship has been awarded to Kilo Juliet 7 Echo Victor Lima, Daniel Lavey of Scottsdale here. And we will be contacting him and let him know that he's got an honorary membership in the club for a year. That is the rest of this year and all of next year. And hopefully we'll spark some interest in ham radio and the guy who's got a tech license so far. Although he's probably going to be too busy chasing girls at college to play radio. But as most of you have heard, we generally donate about this much every year through the ARL Foundation. It looks like there's another 900 clubs that do the same thing. So they give away close to $1 million every year. So AA7A, do you want to take the microphone and talk about Visalia?
Okay. All right. We've been meeting somewhat regularly every 2 weeks for a while here to start working on the convention preparation. At the moment, the representation for the club is myself as co-chair. We have Mike Fulcher, KC7B, who's the program chair. And then we have Larry Lowen, who's is banquet seating. Debbie Finkel and Inta and others are have volunteered, or I volunteered them. I think I got confirmation from Debbie that they will do the hourly prizes. They enjoy that. Gives them time to socialize, and free Diet Pop all day long on Saturday for that at the convention. And we will need some more people at the convention to help with registration and maybe other items. So if you wouldn't mind chipping in a few hours while you're there, I know, the cost of getting up there and staying there and going to the convention is one thing, and then to have to work is is a little bit of an imposition. But this is the largest income that this club gets is from proceeds from our participation, and we will be getting more than we've than before because of our involvement. Now CADXA is now a sponsor of the convention. Our club is going to be on the actual logo, so we've come a long way from being remote DX visitors to being actual co-sponsors of this event. The hotel registration opened up on the 13th of June. There was a bit of a pileup. All the rooms at the convention rate have been booked. We're getting a lot of inquiries about how do we find other rooms in the area. The best instructions we have are on the website. If you still have problems, drop any one of us a line, and we'll help as we can. Registration is a little slower than previous years, but I think all the metrics for this year are going to be different than anything ever before. First time we've ever started a convention after a 3-year break and after the medical situation that we've been going through for the last 3 years. So we'll see how this works out. I mean, the important part for us is to gauge the number of attendees well, so that we don't pay for more than we need. The largest expenses by far is the food preparation or the food costs, and that takes very, very good estimates to get that right. But we'll have to, pay the bills a couple weeks before the convention, so we got to know where we are. We've had a new addition to our team. Dr. Scott Wright, K0MD, has volunteered his services to help as a medical advisor. We don't normally think we need one, but at this time, with all the things that are going on and a potential for recurrences of COVID, we want to make sure we have the right person to help us to find out what we need to do and to find out what we should be doing to reduce risk. We know that a lot of people will not come because of the fear of COVID. And we have to do everything we can to address those fears. For example, I'm working with my daughter to work on a web app that you can download to your phone so that you can do a number of things that you normally stood in line to do. We're going to try to do using web apps. So we're trying to do everything we can to address the concerns. Something that's going to be kind of new this year is that DX Engineering, I believe, is going to be providing some of the major prizes. So up to this point in time, it's been HRO. So I think it's DX Engineering's presence at the convention next year is going to be a much increased. So that's I think that's good. Getting Tim's group into the convention. So the next big thing is we're going to start open registrations. That's coming up later this summer. Maybe it's closer to September. I know pretty soon Mike and I are going to have to get serious about lining up speakers. It'll be a bit of a challenge. There's not that many DXpeditions, so we have to make sure we have a good fair of speakers for everybody because that's one of the big attractions. I mean, really two things attract people, three things really. One is just the camaraderie. That's very, very important to get back together with all your friends. The other is the program, the presentations at the meeting, and the third is the presence of all your major vendors, so you can get up in person and talk to some of the major radio suppliers or the ham radio retailers like DX Engineering. So it's good to have. That's a very, very important part of the offering there. So that's it for now. We'll be continuing to meet every 2 weeks to just work down details and start to get ready for the big push for registration to be coming up. So outside of the personal commitment of people's times and energy, that is the sole thing that we are required as our role as a member of the team. And we'd like to get 1 or 2 people to volunteer to help with registration and possibly other duties at the convention next April. So the dates? Oh, the date? Well, it's I think it's the 18, 19, 20 of April. Don't get me wrong, but it's that part of April. So put it on your calendar. All right, that's it for now.
Okay. Next slide. Israel, are you on the call and do you have anything to report about our DX totals?
I am on a call. At this point in time, actually, I don't have anything yet. I'm working with Larry. He replied to the email today, and I don't know if you had a chance to read the email. So I believe by next meeting, we should have some good reports to do it.
Okay, great. Yeah, I briefly saw his email on my phone while I was at work, and it looked very optimistic. So I'm really glad that you're helping out with that. Okay, so we look forward to hearing more about it next month. Next slide.
Okay, we do have a few things to fix, and I also have some requests. One of them is I am not available due to my work and some other commitments, you know, to be answering emails and things like that. So I will contact you later because I do have a request in that area. As far as producing the report, I'm basically automating everything. So we were going to propose to send the forms, and the members will fill out the forms, and this is going to be put up on a, I don't know yet where, but some folder available for Slack. And I will get the files from there, and from that point forward, we can just automate and produce the reports without too much handling on it. All right, that's all I can say, Bill. Thank you.
Okay, thanks a lot. Next slide. Anything else? Any club business from the Zoom meeting or from the floor that you'd like to bring up before the club? Either something old or something new business. Okay. That'll make it for a shorter meeting. Tom, are you available? November NQ7R. Are you ready to talk about the club activity report?
Yes, I'm here.
Okay, I'm gonna sit down and let him bring up the bring up your spreadsheets.
Okay, can you see the first sheet?
Yes.
I guess we're having problems with my audio a little bit. I have a very slow connection, so that could be why I sound like a robot. Anyway, I got a few activity reports the last couple of days, so I've got everything uploaded. Again, on the DX challenge, you can see Rick has been very active, and Steve also. I know he had trouble with his computer, so he's still sitting at 932 at least for the DX challenge. And I think he'll have more data next month. I'll just go down the line if I can. Yeah, let's see.
Tom, are you there? We lost your audio.
Connection got slower.
Yeah. NQ7R, A4Q. Okay. I suppose we could all look at it for a minute and then step through to the next one and then the next one. HF Marathon. Wait, is it? Is that the screen painting? Here, him do it. Yeah.
He fell asleep.
Tom, I don't know if you can hear us on the computer or not, but we've lost your audio. We're seeing your screen and we're seeing the cursor move.
Okay, is my audio coming through now?
Audio's back.
Okay, I was been using the space bar. Evidently that didn't really work. But anyway, these are our marathon totals. A couple of really high-powered guys, and also with low power for Steve here. I'll just kind of run through here. I guess everybody can read. With the expeditions, we got one coming up in August, and then a few more in rapid succession in the fall. Again, the idea is work each station as many times as you can, modes and bands. 6 meter challenge. We got Lee up in the lead, while 44 countries. Thanks to yesterday's opening, I added probably 8 or 10 new countries from Europe. Was really surprised. I got LX, HB9, MD, and a few others. Was really a great opening for me. And really no change in the last two things here. I haven't actually been very active on digital modes myself. And of course, oops, I forgot to change mine. I do have Zambia, so the 4 of us have worked all the way through the alphabet, except for Yemen. So I guess that's it for me. Maybe I'll try to be in person next month. If not, this works out well for me. Maybe not for you guys. Let's see. I'm going to stop sharing here.
Okay. And I think that was the last item on our agenda, which you can bring up here. Activity report, then QRT and cleanup. Anybody want to talk about anything else before we end the meeting? Okay. Well, thanks a lot for attending, and we'll see you all most of us will see you all next month. I'm going to miss next month's meeting. So Virgil and the other officers will be running the meeting then. So thanks a lot and good DX.